Hello everyone. So in today's video we'll be looking at trie data structure. So in trie we have to implement three different functionalities which are insert, search and starts with. What insert does is it takes in a string which is word and insert it into a trie. Trie is nothing but a dictionary. And another functionality is search, where it searches whether the word exists in our dictionary or not. And also we have starts with. We have to see whether a prefix exists for a certain word in a dictionary. So let's try to look at what trie is. So trie is actually a data structure which is an array tree. Means it has n number of nodes, child nodes. Here it is 26 since we have 26 characters in an alphabet. Okay, so let's try to define our data structure here. So we'll define a struct, say trie node. It will take in a character. Let's name it as ch. C will also do, and it will also require int count and int ends here. And we will need an array of 26 tree node star pointers for each node. So that will be trie node star arr. You can call it as child array, child of 26. And this is our structure. So this will be the main basic structure of our trie. So with trie, what we actually mean is, say we have to insert app in our dictionary. So what we'll do is we'll start with a special character. We can name it as a slash. This is the beginning of our tree. So we'll insert inside this a, and in a we'll be inserting p, and in p we'll be inserting again p. And at p what we'll do is we'll write ends here equal to 1. So what ends here means is that at p we have one word which is ending in our dictionary, and for each a what we do is for each a we have ends here equal to 0. That is because none of the word is ending at a, it ends at p here, so ends here will be 0 and count will be equal to 1. So what count means is whether this is a prefix of some word. If it is, then we maintain a count variable. That means this belongs to some word. And the same will be obeyed for the next p, since the string doesn't end here and there is a prefix which exists for it. So basically at each point in the tree, we have 26 nodes which can be pointing to any of the character direction. And that's how we'll be writing our dictionary. Okay, let's comment it out. Okay, now the first thing we need to do is we need to initialize our data structure. What we'll do is I'll write a function which is like a constructor. I can write a constructor here as well. You can write a constructor here, but I like to write it separately to avoid any confusion. So what this constructor will do is it will return us trie node star, and let's name it as get node. And what we'll pass here is we'll pass an index, say int of index. What index means is I'll define it just in just a second. Say we have to insert the alphabet A. So the value of A will write it as A minus the character A, which will be 0. So we'll be passing it 0. So it will insert at the 0th index in the array, child array, the array that we defined here. So that is the index that we are passing here. So in that index, what we'll do is we'll directly define a try node of temporary, try node star. You can name it anything. Say name it as new try, and we can just uh, write a new function, new and try node. So it will give us a try node back. Okay, so we have made a new node. Now we need to insert values for this node. So what will be the character value for this node? It will be the index plus the alphabet A. So what we'll write is new try. New try will be equal to the alphabet A plus the index. Index is nothing but the value that we are inserting in our newly created try. And the next thing we need to do here is, we know that the count and the ends here will be 0 because the next part is not inserted yet. So it will directly be new try dot count equal to 0, and also new try of ends here equal to 0. And the next thing to do is, since we have this child array of the type try node star, we need to make every child as a null pointer. So we'll write for int I equal to 0 comma I less than 26 comma I plus plus. So children will be empty because nothing is being inserted after that. So we'll write new try dot child of I equal to null ptr. Okay, and after this we'll directly return the new try. So this looks good. So this is our function, and also what we'll do is we'll define a variable, a try node star, which is root. It will be the starting point of our dictionary. So we can write something like try node star root. We define this globally so that each function can be able to access it. Okay, this looks cool. Now let's dive right into our function. So we need to initialize our data structure. What we can do here is we can initialize our root. So our root can be any special character. So what I'll do here is I'll just write root equal to the get node function that we wrote, and I'll pass in the, say I'll write it as a character slash, and I'll pass in slash minus a. So this will return back a integer inside the index, and I'll convert it back to the ASCII value of the slash with the help of this. And that will do for initialization. The next thing we need to implement is the insert function. So insert function is very simple. We only need to insert the values which are not present. If the value is present, then we can just iterate over the path. So for this, let's create a dummy variable. What is the name of our, yeah, try node. Struct name is try only. Try node star temp. Temp is a temporary variable, and we will initialize it with the root. So after that, what we'll do is we'll write for char c in the word. After that, at each point we will check whether this char c is in the child of the temp. So if the temp dot child of c minus a is equal to null ptr, what we'll do next is we'll write temp dot child of c minus of a and that will be equal to get node, and we have to pass in the index, which will again be the same thing, which is c minus of a. So this will insert a new node in the trie, and after inserting this, what we need to do is we need to add the count variable for the node. That will just mean we are going into the children of it. So temp dot child of c minus a and dot count plus equal to 1. What this exactly does is, as discussed here, we are increasing this count by 1 because there might be a substring that we are asked to search in the later part, and we can simply return it with the help of this. So that is done. After that, we have to traverse into next node. So we'll just jump to the next node. So temp equal to temp dot child of c minus a. Okay, so that completes our implementation for the insert function. But one important thing that we missed here is we need to add the ends here as 1. We have to increment it by 1 after the ending of the insertion. So what we'll do is after this, we'll directly write temp dot ends here plus equal to 1. So this is the final implementation of the insert function. Now let's look into the search function. So in this function, we check whether the path exists. Say we are asked to search for app. So we will go into A, then P, and then again P. So the first checkpoint is to search whether the path exists. So for search, check if the path exists, and if it exists, check for ends here greater than 0. If these are satisfied, then we can clearly say that the word is present in our dictionary. So let us implement the functional. So again, what we'll do is we'll write a dummy variable try node star of temp, and we'll equate it to root. After that, we will go inside the word for auto C in word. In this, the first check is to traverse if the traversal is existing. So if temp dot child, if temp dot child of c minus a, if this is equal to null ptr, that just means that the path does not exist and we directly return false. Okay, and if it does exist, we move one step ahead. So temp will be equal to temp dot child of c minus a, and since the temp has been moved forward now, in the end what we need to check is if temp dot ends here is greater than 0, we directly return true, and if it is equal to or less than equal to 0, that basically means there was no word that has been ended at this ends here, else return false. Okay, so the next function that we need to implement is starts with. So starts with is exactly same as search, but in the starts with function, we can only be given AP. So we need to return whether this is the substring of any word. So if you can check, the count value is greater than 0 for it. And if the count value is 0 for the last element greater than 0, that just means that there is a word that starts with it. So instead of the ends here, we only need to change one thing. It will become count. And we need to just write here count. And if it is greater than 0, then we return true, or else we return false. So let us try to submit our code now. Okay, we are getting some error, line 13. Oh, so we need to put this value inside this char C. So it will be, okay, now it looks good. Yeah, also we didn't change this word, like it is prefix. I wrote word. The string name has been changed from that to here. We need to make it prefix. And now this should run. Okay, let's try to submit our code.